To the stream. Today is going to be the first episode of the new game. We've been building Joust for almost 2 years on the stream, and now we are moving on. And we're moving on to something more complicated. It's going to be a Name of the Wind inspired video game, much like Link's Awakening. So that's going to be something I've never made before. It's going to be a top-down. So it's going to be a challenge, but I'm looking forward to it. So I'm going to be building the project from scratch so y'all can see how to start a game from scratch like this in Love 2D and Lua. So first thing I want to do is pull a template from my repo, and I made a template to get me started with Love development, just because there's a couple of boilerplate kind of stuff that is nice to just have. So that's going to be at github.com/findingfocus/Lua_template. So if you do this on your machine, you can clone into this repo, which will give us just a starting point for a little game in Love 2D, just as it's these, couple folders and a main. Now we're going to be changing this stuff, obviously. Let's actually make a new Git repo for our new project. So I know there's a couple different ways to do this. I tend to just do it here on GitHub itself. So I go to repos in the new repo, and it's going to be called what? The Name of the Wind is what the game is, but I don't want to be typing in the Name of the Wind every time. Kavoth DX. Let's do Kavoth DX, because that's the main character's name, and DX for the Link's Awakening DX. Is that stupid? I don't want to type in the name of the wind every single time, so Kavoth DX makes sense to me. So let's say a top-down platformer. I guess not platformer. Top-down game based on the King Killer Chronicles, inspired by Link's Awakening. Okay, public, initialize with a README. Go ahead. So that's our new repo. I guess the repo is case sensitive, so we'll just have to make sure we do a capital DX. Lowercase dx looked a little weird, but here we can go ahead and clone this repo now. So if we go back into our main folder here, we do a git clone using the SSH. Nope, that's not it. What is it? Okay, yeah, let's try that. It should say an empty repo, I guess, if it had the README. So now we should have a Kavoth DX, and then we can ls and see that all we've got is a README. So if we cat our README, it'll say whatever we said. Very simple. Okay, so let's copy over our files from our Lua template into our new repo. How do we do this? How do we copy? We can move the whole folder. I don't know how to move the whole folder. I mean, let's just, for the sake of getting going here today, I'm just gonna copy and paste it. I know there's a way to do it in the terminal, but I'm not figuring it out. We'll take out that README. We don't need that new README. Okay. So we don't need the git or the README, and that is still the correct one, so we should be good. We might make some new music for this game. Let me know if you guys want some new music for this new game to listen to while we're making it. But let's go up into our kvoth.dx. Get repo. We've got a bunch of this stuff. So now we can go ahead and start editing our preset. So we want, we want this to be called, I guess, kvoth. DX. Okay, now we have a bunch of basic stuff. We want to get the actual resolution of Link's Awakening and mimic it, so let's go see what that is. Put in the DX because Twitch did just remaster it. I mean, it's just Game Boy resolution. So what is that, 200? 200 by 200 or something? They've got to have the resolution here. Why is it so difficult to just find the resolution? It's a Game Boy resolution. .160 by 144. That's really tiny, but that's cool. 160 by 144. So let's go ahead and do that. We'll go 160 by 144. Okay, we'll do this for now. We'll do the same setting so we can see what that size actually looks like, and then we'll dynamically scale it so it looks reasonable while we're developing. But we're using a library called Push to dynamically resize all the stuff to a virtual resolution, so that should be taken care of for us. So we've just got, and if you take the CS50 game dev course, this is like week 2 or week 3 kind of boilerplate. So it's like we're setting our filter for the pixels, just no interpolation, setting the window title, giving ourselves a font, giving a table of sounds, which we don't have at the moment, so we'll probably just comment these out at the moment. Actually, we'll keep beep and select because that might be useful for like a title screen state. We can't do full screen as long as we're in OBS and we want screen to be shared, because for whatever reason, when you go full screen, it opens up in a new window and then anyone streaming can't see it. So we're gonna turn that off. And then we've got title state that we are changing to default. We got four states. We got a title, a play, a help. We don't need this. We've got a help state, which I'm going to take that out too. And we can actually take that out here as well, saying like here states, we don't need this help state. We don't need this trip state, delete. And so we've got play state, title screen state, music, okay, fonts, we just got a simple font, basically nothing. Like this stuff is, I didn't write this is just a library someone wrote for a state machine. It just allows us to change the states and render only what's in the current state, so there's that. To enable kind of object orientedness in Lua. I didn't write that either, and same with this table for dynamically resizing. So that's kind of like all of our boilerplate that we need to just get stuff running up on screen so that we can see it and tweak it. It's not too much, but if you don't know how to use those libraries with Lua, it can be a little daunting to get stuff like resizing the screen working fairly easily. So now we've got that working fairly easily. So we can go ahead and clean this up a little bit. We've got this stuff. We'll probably move all this into a separate like dependencies file, but not just yet. So let's set First thing we're doing is changing to a title state. So let's get our harpoon set up actually, because right now we don't have anything in harpoon. So we'll go to our states and we'll go title screen state. We'll get harpooned, and that'll be 1. And then we'll go play state, harpoon, that'll be 2. That allows us to switch between those files without even thinking about it. So thanks to Primogen on that one. And we're going to be going, we just want something on screen, right? So this, ignore this. This is going to be, you know, just what we set the screen to. So like what color. So let's say we want a more blue screen to be flush with it, perfectly opaque. We'll do that. I'm curious if this will work. And it does work. So this is the Game Boy Color resolution we're working with here. We're actually rendering our FPS there. So we've got our game working at 60 frames a second with not too much work. So there's that. So let's get to the good stuff. So like, let's do, we don't want, I'm gonna instead say we don't do the title screen state just yet. We're gonna go in our main, we're just gonna set ourselves, I didn't add our main to harpoon, which we'll go to. So now main is L, okay. We're gonna change to play state right off the bat. And then we want to, let's say in our play state, let's just take a look at it. We don't need this. This is more boilerplate. We don't need this. We don't have help state anymore. Yeah, we can, this is all just old boilerplate I kept in there just in case I wanted to know how to do scrolling backgrounds and stuff. But we're doing completely different stuff in this game. So our play state's gonna look pretty bare. It's gonna be setting the color, which we'll do, let's just do something a little more blue. And then we'll take off our FPS because it is just so tiny, and that's in our main. So like this is how it is. This is a state, right? So all you do is you inherit this base state class, and that'll give us certain functions like state machine change, which allows us to render new things and update new things and kind of control the flow like that. We don't need any of this stuff, like, yeah, we don't need any of this. So all we're doing in our play state is just rendering a color. Okay, so if we take a look at what that is, we're still rendering the FPS because that's in our main, and we'll just turn that off right here. So we're rendering a blue. So let's get this size a little more appropriate for us to be looking at what is on the screen. So we'll go here. If we go, where is it? In our main? Yeah. So if we change our window height, that'll change. No, virtual width. Let me just see. Let me see if we double this number. So what is it, 320? 320 to 288. I'm not remembering if the virtual resolution is what it renders to. No, that's okay. So we're gonna keep that. We're gonna keep this as the original resolution here, and then 288. This I already messed up, but we're just, you know what, and maybe we probably need to like multiply it by 4. So I'm not gonna do math on stream here, but I'm gonna do 320 times 4 gives us a 1280 for a width. That's fine because we're streaming in 1920 width, so that should be okay. And then 288 times 4 gives us 1152. So 1152. Okay, so now if we run our game, it's a little bit bigger. So what's... I was thinking it was going to be much bigger. Because if we do, let's say, 1920 by 1080, should be full screen, right? Because... Huh. Okay. So I don't exactly know what's going on with that. Because that's obviously not the same. Are we resizing? You know what, I think... Let's say, so let me just add the comment here. 320 by 288 is Game Boy resolution. So let's give us a window of 1280 by 720. Just so we can see that size, get the size right. Okay, yeah, so it's going to be square, but it needs to be a bit bigger than that. So which of these changes how big that screen is? Not the virtual resolution. But if this goes bigger, okay. So let's say, let's try to multiply. So we want to render to, I guess I'm still a little confused how Push is doing this. Because we're doing virtual width, virtual height, window width, window height. So we need our window height to be a multiple of our virtual width. So this will be, let's do this times 4. So 320 times 4 gives us 1280. Did we already do this? I feel like we... No. This will get us the right aspect ratio though. So 288 times 4 gives us 1152. We already did this. Let's see. See, that's looking better. That's looking more appropriate. Still a little too big. So not quite times 4, right? So we just want to make sure nothing's getting cut off. So let's see what the... Yeah, you know what, AKA Bob, are you watching? I just Googled Game Boy Color resolution because I got this. Yeah, oh, you're right. Yeah, I already doubled that. Okay. So yeah, we'll do this to be the original. I forgot I doubled that number already. So what if we multiply this number by 3? I think that'll be so pretty. Here. There's a better way to do this. Let's get what the aspect ratio is, and it's 1.11. So if we know we want about 1280 width, then we would need 1280 divided by 1.1. No, that's the same thing, man. That's the right. So how do we, if we want it like, let's say 1,000 wide. See, but I don't want to get it. I just know the pixels are going to look weird if we scale it by something that doesn't divide so equally. So like if we do 1,000 by 900, that's looking pretty good. And then it's exporting to the virtual resolution of, we want to do this original resolution here. And then Now it should be the same size square, but as far as love is concerned, it's only that original Game Boy resolution. So if we draw a little tiny sprite, 10 by 10, it'll be the appropriate size. So, and actually maybe we go ahead and do that and give us a little sprite and see. Let's see, Link's Awakening sprite. Just want to see how big their sprites on their sprite table are. So we can make our own similar sized one. Yeah. So like how many, what are these pixels? Yeah, look at that. That's what we want. So how big is that? So here's where we can, let's go ahead and save this. And we'll go ahead and open this with a sprite and we'll kind of look at it. So I want to open it with a sprite. Let's just open up a sprite and just import it. Here we go. So let us just take Link Sprite into here and we can start looking at it. So it's probably, I don't know what the default size of sprites are, but if that is 1, we can, yeah, okay, so that should be size 1. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 wide. 13 wide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17. 13 by 17. But that's assuming we're using all the way to the left and all the way to the right. 13 by 17, that doesn't sound right. 16 by 16. Okay. So there's our answer. So let's make a new canvas, 16 by 16, and see what this looks like. So we'll say 16 by 16, and I want to use all the original like Game Boy palette colors, right? Too. So we'll take Link right here. We'll see how he looks 16 by 16. Okay, there we go. No. Why is he? No. Why does he look? Okay. What is going on, man? Okay, I don't know how to do this. It just cuts him off because we already pasted it here. Okay, so far so good. Yeah, look how cute he is. Okay, so it looks something like that. And when he's centered, it looks something like that, I guess. So let's make our own. If we have this as a sort of template, this is a 16 by 16. Let's see what a 16 by 16 would look like in our game, just to see if it looks appropriately sized. So in our play state, we'll go and we'll use a function called love.graphics.rectangle. And it takes in an argument of a fill type, which will give it fill instead of line. And then we'll render it at, let's say, 0, 0, which will be the top left. But we don't, this would render a same color rectangle as the background, I think. But we want to set the color explicitly to something like red so we can see it. So pull up on the R, 0 on the G, 0 on the B, RGB, and then full alpha for transparency. And we'll see if we're doing that right. And we're not. Rectangle number expected. That argument 4, so we need a fourth argument. So there's another argument to love.rectangle, and it's a width and a height. So we need to tell it how big, not just the starting point, but we want, is it 13 by 13 or 16 by 16? I already forgot. 16 by 16. Okay, so we've got the square, hopefully there. So that's about the size of one sprite, which looks about right. So if Link was that big, or if Kavoth's that big, that looks about right. So let's continue on making him. And we'll make a new layer down here so we can just draw our own. I don't know where my layer stuff is. There it is. So, like we've got this new layer so we can kind of draw our own character over top of this. So Kavoth's got, red hair. We need the Game Boy palette. It'd be nice if we had the Game Boy Color palette right here. So maybe we can do that. It's probably gonna take forever. Let's see if we could do it fast. We want here we go, that looks right. So if we have this into our game here, we can kind of choose from these colors. So this is, can we just copy and paste this? Nope. Really? Here. Okay, so there's the green. How do we get... I don't know. I'm trying to just overwrite this palette, like, how come we can't change the palette? They're not saving. I'm not so good at using eSprite. I'm tempted to just move on, but if we had this, this would help developing all the art for this thing. I just don't know how to do the palette. How do I do a custom palette? Just can't get any of those palettes to save. Oh, there's one. How do I do that? Okay, so if we paste the color into the top button here, then if we hit this button, no, this button? Dude, how do we do it? Oh, okay, we have to hit the exclamation mark. Okay, so let's go ahead and get our palette going here. This isn't too bad. If I just knew this from the get-go, would have been a lot less embarrassing. Okay. So, one thing I'm wanting to do with this game is almost like a, I don't know what to call it. Like, you know in Pokemon Gold and Silver when it becomes like nighttime, like there's a real clock, and it becomes nighttime, and then everything has got that blue tint, and then it's got like that nice warm glow of like windows and stuff. I want to do that for this game and have a kind of time system. So like we'll have like a base color palette, and then, you know, as evening approaches, it gets bluer so that all the yellow candlelight and lanterns and stuff will be that really pretty orange against that blue. And then when it becomes morning again, it's nice and orange, and then most of the day it's just normal color palette. But it'd be cool. And then like I'm also thinking in Gold and Silver when it becomes nighttime, the character sprite is actually still kind of bright. So like the character doesn't really get dim with the world. I'll show you guys an example of what I'm saying here, but let me finish this first. I just love that style. Like Link's Awakening and Gold and Silver are probably my top like nostalgic games to play. And when I think of making games, like I think of those games. So I know this is a pretty ambitious project, but this will be my ambitious project, and then I'll do like little game jams on the side where I do different programs, different types of games as well, so I don't get so caught up, because it's going to take me a good long while to build this the way I want to. Then we have black, and then we have gray. So let's get this gray, and then we've got our little palette there. And then I'll save this palette. How do I save palette? Save palette. Save palette under documents. And we'll just call it Link Awakening palette. Okay, so if we ever lose that, I don't want to spend that time doing it again, but we've got it now, so we can make our own. I want to show you guys the, what's that? Pokemon Gold at night. You know how everything's blue except the characters? Oh yeah, see? How like they're still the same colors, but then everything else gets kind of dark, and then the yellow lights come through. So I want something like that, because I just feel like that was always really cool. I think that was like a limitation of the Game Boy at the time, but it's just really nostalgic to me. Okay, so let's make our own little guy here. Is there a way to take my transparency down? I'm more of a Photoshop kind of guy, but okay, let's just this is nothing, so anything we draw will be over it. So let's just get the shape of the head, right? Like shape of the head would be pretty much the same. So if our eyeballs are in the same spot, and we had sort of our hands in the same spot. This is like to give us an outline of what it can look like, and then we'll kind of change it from there. So if that's our starting point, See, like I wouldn't have guessed that that's what our starting point would look like. And then we've got maybe his sidearm there, so. Okay, so if we change all of this to black, then we can start kind of sculpting what he should look like. I just did it orange like that so I can see what I had done. So if these are his sort of bodily outlines to start with, that's the bottom of his head. So we can draw him, you know, he's got to have that fiery hair. So maybe he has only hair up to there before his hair starts kind of overtaking it, because it should be fairly hairy of a man. We can give him maybe something like this. And then we need that hair, man. So if this is his kind of wild outline of hair, kind of like whooshy hair. That doesn't look so good, does it? Maybe some wild hair like that, and we can fill in the spots with orange or something. I know pixel art is like way harder than it looks in order to make it look good, but we're just trying to get something. And I'm probably spending way too much time. We probably shouldn't be worrying this much about it, but for me, if I get a character on screen and it's my art and he's responding to movements, then that's like most of the fun of the game development. Is like, that's my character and he's moving, then I can go and do all the nitty-gritty of everything else. That's the but like that's the kind of, we need that to get going, to get that inspiration cooking. So if he's got hair like this, we might need like he might have like a top of head part, and then whooshy hair. I don't know. There is something really cute about the limited graphics here, right? So like, see, the hair doesn't have much volume here. It's hard because we can't outline everything with black because there's just not enough lines. But if we, maybe not that. Yep, okay, yep. Okay, so we've got orange hair, orange hair, white skin, I guess. Maybe yellow skin. Oh, that looks weird. Give him that skin. What color was Link's skin? It was that gray, yeah, it is that color I got. And then, he's only got very little skin kind of showing. And then he's got his little feet. You know what? He's got to have some red hair, right? Not like... Oh, actually, I kind of like the red hair. That looks pretty awesome. Yeah, I actually kind of dig the red hair. So, like, he needs a little bit more volume, right? So, like, he can have hair come up to here. And he can get his hair volumized. Okay. He's coming along. I don't like the blocky side here. We'll have to fix that, but let's take a look at the feet. So like, it looks like one foot is showing. So like for the animation, it's kind of like left foot, right foot, left foot, right foot. So if this is his left foot, then we can make his left foot show out kind of like this. Let's just leave this on so I can see. It really does. See, like, it's weird, like when you're designing pixel art, you wouldn't say, hey, I'm gonna put a black pixel right here on the side. It doesn't look right. But then, you know, if you think about the shape of it and what kind of shadow it would cast, it really does kind of look like that. So as weird as it looks to put a shadow way out there, it's pretty accurate. So if that's his foot, and then his other foot is behind, it would look something like that. And Link's foot is part of his tunic color and then part of his skin color. So if we have skin color, nope. Skin color and then tunic color. So Kvothe would probably wear like a dark brown kind of tunic or something, right? So it would look something like that. And he's got skin color showing too. Okay, so tunic. If we can draw similar, it's like there's only so many combinations of pixels you can do to make it look good. So I'm gonna trust Nintendo on this one, had it fairly right. So we're gonna add a little more shape to his hair. It should be a little more unwieldy. It's just so hard to make it look good. Because he should have some hair kind of playing out. God. If we had, so we do have this other red to kind of work with, and we can maybe texture it a bit with that. Let me just get, you know, that's looking not too bad. Yeah, this is looking not too bad. That's what we go for on this channel, not too bad, apparently. Let's, okay. It's cute. It doesn't look, I want it to look like unwieldy, like fire. And it looks like it's just kind of falling in place right now. So maybe, how do we give it more shape? Like he needs almost, we can't really have strands of hair because it's a pixel thick and his eyeball is a pixel thick. So it's like, maybe we just call this good for now. Yeah, maybe we just call this good. It is cute. It is cute. I like it. Let's start here and then we'll get more in depth when it matters. So let's go ahead. We'll save this. We make an A sprite folder. And this will be Link's Awakening Pimple A sprite. Let's do both attempt 1.a sprite and then we'll export a Kvothe PNG. So I maybe don't like, yeah, maybe his hands or something like that. Oh, that looks like weird. Yeah, maybe that. Okay, because his hands kind of, if his hand's walking with his feet, it would look maybe something like that. So we can say, export this guy as a PNG, and we want to put it, we can call it Kvothe. We'll put it in our repo under source, right? So we'll go to our repo, and we don't have a folder here, so we'll just make one called source, and then we'll make pics, and we'll save it here as Kvothe PNG. Okay, so it doesn't support layers. Okay, yeah, that's okay. It was, oh, okay, we had, yeah, we need to flatten this. So if we don't need to flatten this. Let's just color what this is over it. so that we have it. And then we don't have to get rid of link, because it's nice to have as a reference. And then we don't have to flatten it. Okay. So yeah, and actually his tunic is peeking out, so he has like a square hand. I mean, we don't have to. I don't know how much it's okay to steal Link's Awakening. It's only 16 by 16. It's hard to make it. You know, there's only so many shapes that look okay for a person. Yeah, I like that. So we'll go save it. We'll export as a PNG, and not all frames, or all frames, but only one layer, only layer 2. Yep, okay, and we'll overwrite that. Okay, so how do we get that in Lua? Let's do it. We'll get it here. I should say in Love 2D. So we have our drawables in our main, I guess. We can move them, but what we're gonna do is just say, we're gonna get a love.graphics new image. And the image is a file path, so it'll be source pics / Kvoth PNG. And then I believe that's all we need. We have a love.graphics new image, but we need to do something with that image, right? We need to save it. So we'll put Kvoth 1 gets that image so that we can actually draw it. And then if we go to our play state, instead of a rectangle.fill, we're going to do a love.graphics draw call with a drawable, which we saved at our Kvoth 1. And we're going to draw it at a 0 and a 0. X and Y. So very top left, just like our square is, and then a width and height of its width and height. And then I'm just going to go comment this out so we don't draw the rectangle behind it. And I'm not seeing it. So we might have done, let's see, love.graphics.newImage. Yeah. It might, I think I might need a slash here, maybe not. Okay. I mean, this is game dev for you. Whatever you think you know how to do. An X or Y, maybe it doesn't need a width and a height. Okay. So we've got a little Kvoth there, and it's all red, and it's all red because we just set the color to red for the rectangle there. So what we'll do is add our love.graphics.setColor, and we'll set it to, and there's got to be a better way, instead of doing these values, like, I'm wondering if we can do like a local variable called white and get it set equal to a table of values of what white is, and then we can just say love set color white. I'm curious if we can do that. Because if we have that and then we just say set color white, that would be kind of cool. Nope. Play state 11. Oh, we need to end our table. Really? Okay, we did that for some reason. Hey, you can do that. You can set it to white and then just do that. See, this is what I was worried about. This, like, his eyeballs don't look even. He's got like a lazy eye because it looks like it's not. I don't know. It looks a little wonky, at least to me. Let me let me do something here where we can say, like let's say we've got a player X value that gets set to 0. And we got a player Y value that is set to 0. And we say, in our update function, we can say if love.keyboard love.keyboard was pressed, love.key was pressed. We have love.keyboard.keys pressed and then was pressed. There's also is down, love.keyboard.is down, I'm pretty sure. So maybe we can do that one. Love.keyboard is down. That's not right. Let me see what that is. Love.keyboard.is down. It was right. Okay. So we're going to try to add some simple movement here. So we're going to say, like, if our right key was down, then we're going to do, we're going to say that would mean that our player X would get updated to be our current player X plus whatever our velocity is, right? So we can say velocity. Let's just call it, oops. Yeah, let's just call it velocity for right now. And we'll just see if we can get it to move right. So we're not trying to draw a Kavoth at 0, 0 anymore. We're trying to draw a Kavoth at a player X. And then Y is fine at 0 still, because we haven't done that yet. But if right is down, we should increase our X position by a velocity. And we can set that velocity here. Let's just say 1 for now, because I don't know how fast it is with a tiny screen like that. Hey! So we can't move right, but we can't move left, but we can move right. So let's go ahead and add the rest here, where we can say, you know, if left is down, then go ahead and move left. If down is down, you know, up is down, all that good stuff. So we'll say if our left is down, then we're going to subtract our velocity. And if our down is down, then we're going to add our velocity to our player Y. And then if up is down, then we're going to be moving our player Y negatively. So we subtract velocity. And now, with any luck, oh, okay, well, down is, oh, we're only drawing it at 0, so we'll make sure to put player Y here, and then we should be okay. Nope. Okay. Yeah, because we're assigning it into player X here. So Y and Y. And this is why they say don't copy and paste, because you make silly mistakes like that. But we've got a little Kavoth. So you know what? His eyes don't look too weird to me. I guess it's just when he's up in the top left corner. Well, I don't know. It looks, I guess not. I don't know why. I guess it's just a funny angle. But we got little Kavoth here. How cool is that? Now, I saw a tutorial at some point showing how, like, if multiple directions are inputted, it's actually moving twice as fast using this method that I'm doing, because it doesn't account for, it's moving left 1 frame and down 1 frame when it should move the same distance over time instead of both distances over time. So this is actually twice as fast as just going one direction. So we want to normalize to the vector or whatever they called it to fix that. But this is what I'm talking about. Like if you have, now that we've got Kavoth on screen and he's moving with my keyboard, it's so much easier to just be, you know, wanting to make more progress on this game, because it's like, look at it, it's mostly done. But yeah, like if we had the idle animation, or if we had, you know, all the directions going on, this would be fun as is, just because it's like, dude, that's Kavoth. I'm playing as him. So I guess we can clamp our directions here, and maybe we add a class for a player like this, or for an entity. No, just for a player, because it would be kind of cool if we could. No, yeah. We'll make a player into a class so that we can do. Because I eventually want to be able to go into the Waystone Inn, talk to Chronicler, and time travel back in time to a young Kavoth, which would still require a lot of the same stuff, which is like the same pixel size, still move with inputs and stuff, but new sprite and everything. So we'll move this into a class. Now, you know what? I think his eye really is a little swollen. Yeah. Maybe it's an optical illusion. Does it look like one of his eyes is swollen sometimes? I don't know. I'm curious if we go into our main here and we go, if what we do, we can do like we take this and we have like a non-screen changey one. So like the real resolution is the virtual resolution, so that it's not changing any of the pixels. Because I think something's happening on the resizing that is making one of his eyes look swollen to me. And I don't know why. Oh my god, it's so small. Yeah, his eyes look perfect. I don't know what I was saying. Yeah, look, can't see a mistake there. That's the ultimate game hack. Just make the game so small, can't see the mistakes. Okay, well, I feel like it's because this resolution we're going for is not a multiple of the original resolution. If it was, you know, like if we, because it can't resize something to, like it can easily resize something to 4 times its original size because it just quadruples every pixel. But I feel like anything more than a multiple, or anything different than a multiple of 4 would be not accurate when it scales it, because of the way the pixel scaling would have to work. So looks like we might have to deal with wonky eye for a bit, or if we find a different resolution that is a multiple of this one, then maybe, let's see. So if we take our width and we multiply it by 5, that gets us 800. So what about multiplying it by 6? 960. So let's try this. Let's try 960. 960 width and 144 times 6, 864. 864. Let's try that. Okay, I don't see wonky eye problem. Yeah, I don't see wonky eye problem. Okay. Cool. So we'll keep that for now. That was a this was a better resolution. I'm gonna do slightly lazy eye. And I like that resolution better, but it's not the it's not good. We'll probably end up deleting that, but we've got the starts of our game. Let's maybe make our background color the same color as our palette, so that it's a little more pleasing. So maybe our palette for now is going to be this gray color, which is a 140, 140, 165. So 140, 140, 165. So if we do our little hack from before, 140, 140, 165, let's see. Go to our play state, and we'll give us a gray color. And it'll be 140, 140. $165, was it? And then full transparency and the table, and we can set the color not to this blue color, but we can say set this to our gray, and that's working. Cool. So let's clamp our position so we cannot move outside of our screen bounds. We'll ultimately add a little HUD down at the bottom, just like Link's Awakening's got. But let's clamp it. Oh, no. Let's clamp. So all we have to do is say, at the end here, I guess we would say if our player .x plus 16 is greater than our virtual width, then yeah, and you know what? We can do this better. We can update this. We can say player.x gets an updated version of a math.minimum. So the smaller value between whatever our current x plus our velocity is and our max x position, which would be a player x plus 16, which is its width. So math.min will be that clamping behavior we're looking for, hopefully, so that it can't go past the right side of the screen. It's not working. Maybe it's window width, no. Oh. Math.min. Okay, yeah, so it would be the right side of the screen, so virtual width minus our x position. Is that right? Not quite. It does clamp it, it just stops me over here. So we're assigning our player x smaller value of this versus, let's just see what that gives us. If we clamp it to the virtual width, it should go all the way off screen, I think. But then it's right there. So yeah, we would just clamp this by a minus 16. Okay, so let's do our left, and we're gonna say this is gonna be a math.max, and it's gonna be the bigger value between our velocity and 0, because we can't go further than 0 to the left. So we clamp to the left there, which is good, and then we should clamp to the right, which is good. So let's clamp up and down. Then we'll move some of this into the class, player class. I'm just trying to see here how to. Oh, there we go. Okay. Okay, so we're going to clamp the bottom position to be math.min. So we'll say math.min of our player y velocity clamped to the virtual height minus our player's height. And then up would be a math dot. Actually, yeah. This one would actually be dot max because we want the. Oh no, I had it right. Yeah. Okay. Math.max, the higher of either 0 or our player y minus our velocity. So we'll add 0 there to clamp it, and then maybe it'll be clamped. So we can't move past. That's looking right. Okay. Cool. Sweet. I want to add this into a class so that we can do things like self.x, self.y, kavoth.x, kavoth.y, that sort of stuff. We could do it with our player x, but I want it to be associated. I want all those values. I want kavoth to have a velocity. I want him to have an x and a y. So let's get us a kavoth class here. So in our play state, it's actually going to be in our main. We're going to have to require a class that we're doing. So I don't think we have a states. Maybe we make a folder here. How do we make a folder? Yeah, I don't know how to make a folder. How do you make a folder in netrw? I know how to make a file with %, but that's not what I'm looking for. We want a folder called classes or states. No, yeah, classes. Let's give us a folder called classes. It'll be source. Actually, it'll be, I want to say it'll just be here. Classes. And then here, we can go back to netrw because I know how to do this. So classes, and we % a player class. Yeah, it's only gonna be one player, so we're gonna have a player class, and it's gonna be called player.lua. Okay, now we have to do what? We have to say it's something like gets class brackets, something like that. I think it's like player gets class, something like that. And then we need 3 functions, one for our player init, and then we need one for our player update that gets given delta time, and then we need a render function, so function player render, and I'm missing something here. I think we have to, let me see. Nope. You know what I'll do is, and you know what, we forgot to make a tmux session for this. We'll go ahead and do a tmux new session called kavoth.dx, and then we're going to be in it. We're going to rename it saying first episode. Okay, cool. So yeah, let me do something real quick. And I'm gonna go to our Joust directory and I'm gonna take a look at we do put our classes in our source. So change directories to our source. And class, we've got a class.lua. So yeah, we need, like, let's just say we look at our jockey class and or vulture class. It really is as simple as what I did, which is just brackets. So like, as long as our class table is there, we should be able to do that. So we're gonna go into our folder here and we're gonna go to our classes. This is where we need our dependencies class. So I want this file to be with the class, I think. No, we don't need it to be. It should be in dependencies. So we can do that a little later, but I think that's okay. So let's see if it'll allow me to even interpret that. It doesn't crash, so we might be okay. Oh, I just got out of Tmux. There we go. Okay. So we're going into our both. Okay. So what we want to do is give us access to this class, and then fill out its properties, and then see, because this love.load is getting a new image of Kavoth. This should probably be in the Kavoth class, or in the player class. So that's the first thing we'll do, is put it in our player class. So we're going to say Kavoth1 gets that. Now, instead of doing all this update logic in our play state, we're going to take all of this and put it in our player state. Not player state, player class. And we need to harpoon our player. So we've got that. Now our update function is in our player class. Now we also need all of those values here and all the rendering, so we'll just kind of steal a bunch of that. And this, we'll keep the gray, and we'll take the white. Take the gun, leave the cannoli. So we'll take the white there, and then we'll take our actual Kavoth render. So now, instead of our play state being jumbled up with all of our player function, what this allows us to do is say, you know what, we're gonna have we're gonna keep that as that for now, but we're gonna have a self.x and give that 0, and then we're gonna have a self.y, give that 0. We're gonna have a self.velocity. I'm just gonna call it dx for now. So, and you know what? Let's keep it as that dx for now. Okay. Okay. Substitute velocity with self.dx. And I escaped before I did it, man. Okay, substitute velocity with self.dx. Then enter, not escape. Okay. Now we want player X, we want to substitute that with, and we want substitute player X, substitute it with our self.x. Okay, and then we want our player Y to be self.y. So we say substitute player Y with self.y. Okay, and then when we render this thing, we render self.x, self.y. Okay, I think that'll work. Maybe. Let's see if it crashes. Well, we don't have input. I know why. We're putting everything in this class, but we're not doing anything with this class. So in our update, we need to say, we actually need a player instantiation of this player class. So I'm gonna call it player, maybe. I guess we'll call it both. And we'll init. In our play state, we're gonna instantiate a kaboth, and it gets a player class instantiation. Now it doesn't take any arguments, but in our play state, we then need to go kaboth update delta time, and then we need to render that sucker by saying kaboth render. So both render. Okay, now we've got, yeah, I'm gonna take this and put it up here because maybe we'll make it global colors. Maybe we'll make global colors in our dependencies or something so that we can change any color to our palette if we just know the word for it. So we don't have to sit there and type in 255 over 255 over 255 over 255, alpha transparency, any of that stuff. So like we'll just save a bunch of tables like this with our color palette, and we can just say green 1, green 2, blue 1, blue 2, red 2, 1, 2, R2, D2. Okay, so we're rendering our kaboth, we are updating our kaboth, and we gave ourselves a kaboth to do those things. So now maybe it'll work. Nope. Global player is a nil value, so player is our class called player. It's a lowercase player, but then it gets a capital P here, so maybe it is called player. Nope. Okay, well, we need to, we're not requiring our class. So if we go into our main, we aren't requiring our class here. So we'll go require, what was it, classes, and then it is player.lua, but we don't need that, we just need player. It's a capital P, right? Is it a capital P? Lowercase p. So we want a capital P. Okay, so we're requiring that class, so now it should know what we're talking about. And we're actually moving now. So we've got a little class, and there's a hide mouse cursor button. It's something like love.mouse.setVisible. Something like that. So in our love.load, I'm going to just do that right here. I'm going to say love.mouse.setVisible. That doesn't sound right. Oh, it was right. It was right. Now I don't have it. Okay, but what if I did want it back and I wanted to see it? What I can do is say in our update function, I can say if love.keyboard.was pressed and the key we're looking for is tab, then we're going to set our visible to be swapped. So we want like a ternary operator here. So we're going to say cursor gets cursor and true or false. I believe that's the ternary operator. And then we can go ahead and set our visible not to false, but to cursor. And maybe tab will now change it. But it doesn't seem to be working. So we're messing up this somewhere. Let's see. Lua ternary. I thought I had that down. Let's see. Okay. Oh. So you test for equality, question mark. What? See, you can usually do and or. How do we do it in TAC? I know we do this in TAC. And it's fairly simple. I thought it was just the ternary. Where is it? Is it in the main? Probably. Dot cursor, what is it? Oh, look, so we set visible.false, and then where do we check if tab is pressed? Okay, well, so if the key is pressed, we're just setting a mouse state to be equal to the opposite of if it is visible. So that's a good way to do it. So is visible is going to give you true or false, and we set it to not is visible. So instead of this, we would do something like we can say I like that they kind of had mouse state gets the love.mouse.is visible. So if it is visible, it would be true, and then if tab is pressed and it is true, then we would get not true. And if it is false, it would get not false, which would be true. So then we just set visible to our mouse state, and that should have the ability of toggling it on, which it does. So now we can, it starts us off, but if we want our mouse back, we just hit tab, and then I can point at things. So that's looking good. I don't know where I want to actually do that. Maybe let's get, I think for the last thing today, we will put a little HUD at the bottom, just like, oh, and you know what? I'm back in my Joust. Back in my Joust tmux, which is not good. Let's detach. we'll go. I don't know how to view sessions. Okay, well. Tmux new session. Okay. Let's make sure. Okay, cool. Not bad for one day's amount of work. I mean, it's very simple. But if you tell me that this is a name, like, if I look at this, I'm like, that looks a little bit like Link's Awakening, and it looks a little bit like Kavoth, so I think that's a pretty good success. Let's maybe get that HUD on screen. You know what? We'll save that. We'll do that. We'll do that later because that won't be helpful for developing the game. We want to kind of, well, you know what? Yeah, we want that final resolution because we don't want to be programming things without that resolution accounted for. So if I grab a still from the game, what we can do is open this up in Sprite at a same resolution, right? So like we can say we know our resolution for the Game Boy is what? Our resolution is 160 width by 144 height. So what we can do is do this 160 by 144, paste in our still, because if we want the same, you know, to be screen accurate to the game, get our link still. Oh my God. But we want to put this on our Game Boy resolution. So we'll put it here, just size it appropriate. Gotta be a better way of doing this. Okay, so. This is just a way we can try to get that same exact ratio, right? So that looks about full screen there. So if we take this color or this area and hit new, this canvas size is 16 by 160, which sounds exactly right. It sounds one sprite height tall and a width screen wide. So we'll do 16 by 160. That sounds exactly right. So 1/10 of the screen is that little HUD down there. So let's go ahead and add that as a sort of placeholder. What happened there? Dude, what? What? Why is that over there? Is that a Sprite thing? Okay, yeah, it was an Sprite thing. Okay, so let's go to our play state, and what we'll do is we'll set not our gray color, but we want maybe, oh great, and then our palette's gone. That's why I saved it, just in case. Thought it would do this. Load palette? Preset? Okay, there's our palette. So if we want this skin color to be the palette, we can have this called like yellow. Yellow is 255, 255, 140. Don't we already have that? 255, 255, 140. No, we don't. So 255, 255, 140 is our yellow. And we can say 255, 255, 140. And then that will be our yellow. And then we could render a HUD. And we'll take that after our Caboth. What we want to do is set our color. So love.graphics set color to our yellow, and then we will draw a rectangle. Love.graphics.rectangle. Now this takes in the fill type, which is fill, an X and a Y, and the X is going to be 0. The Y is going to be virtual height minus 16. And the width is going to be virtual width, and the height is going to be 16. And that should give us the HUD at the bottom placeholder. Nice. So our Caboth doesn't quite, it goes past the HUD, which we don't want. So we want, wow. And we're lagging. Probably because I'm rendering all this crap. Got a billion things open and streaming and recording, but let's set in our Caboth player state, right? Well, this is now different because we changed that to be a capital P. So we'll re-harpoon that with the right one, and we'll say we want our screen limit. And you know what? This would be better off in the constants. So what we'll do is we'll give us these as a constant, and we'll require our constants. So here in our source, we'll do a file called constants Lua, and what we'll do is put every constant here. I want to put that this is Game Boy resolution, and in our play state, no, in our main, we want to require our constants. So we'll do require our source / constants. And we'll see if that works. Constants not found. It's not in Sicker, it's in source. Okay, so now we don't want to move down to the bottom, we want to move down to the bottom of the HUD. So we can take this out, and we can do in our player class, we can say, and this is where we wanted to should have harpooned our constants, which is easy enough. We want this screen width limit. Which is 160, but then the screen height limit is gonna get our virtual width. Virtual width. No, virtual height minus 16, which is our height. So now if we set this to a screen height limit in our player class, instead of a virtual height minus 16, and actually we need the minus 16 for our player, and what we can do to be more verbose about that is screen height limit minus a self.height. So, and will give us a self.width and height of 16. And yeah. And then write down self.width for here. Okay, so now do we stop at the bottom of our HUD? Yeah, we do. Cool. It's super laggy. I'm probably gonna have to kill the matrix in the background. Because we are definitely lagging. Okay, let's add us a notes file for the game. And maybe we'll put some text at the bottom of the screen there so that we can that's just our player. So what we want to do is go to our play state, and we want to say after we render our HUD, we're going to do a love.graphics.setColor, and we want to set it to black. And here is where I was thinking we could set all of our constants. So like we've got that, we'll put these color constants here, and we'll say that black gets the black value, and then we just have to make sure that the fourth value here, okay, 0 to 55, comma, 0 to 55, comma, 255, 255. Okay, that should be black. And we just want these to be color constants. So we'll put them all caps like that to be all color constants. Nope. Okay, and then we'll go back to our player and we will do, we need white. Where did white go? White is right here. So we'll put white in our color constants as well. And we'll go. Okay. So here we go, set to white. And then in our play state, we want to set this to yellow. And we want to set this to gray. And then we want to set this to black. So that we can render a little text here. Love.graphics.print. This could be the first printing we're going to be doing on screen, and we're going to say we're going to call it kavoth.dx right in the center. So what we want to do is actually a formatted string. So we're going to say printf, and a formatted string takes a string, and then it takes a limit, which is the width to wrap. So we'll just do a virtual width. A limit and a line mode, which would be center. And then it takes a X and a Y, I think. So if X will get centered, so 0 is fine, and then Y would be our virtual height minus maybe 10 pixels or so. And then we'll see if that renders. Lua 13 under constants, we're not. Yep, we did this. Okay. Set color, number expected got string. So set color, it didn't like that. It thought this was a string. What line was that? Argument 1 on playstate 22. So playstate 22. It didn't like, oh yeah, we passed in a string. We want the variable that is a table of the color. And it doesn't like it. Set color, number expected got string. I don't think we saved it. Printf, number expected got string, okay. 23. Number expected got string. Bad argument what? Bad argument 3, number expected. Okay. Limit X, Y, limit align, maybe? So maybe it's this first. Oh God. Okay. Limit align, okay. So we give it the XY, then we give it the limit, then we give it the align. Is that what you want? Hey, it's just so big. So what we need to do is in our main here, go set our pixel font. Yeah, we have to set the size. So we'll see what 12-point font looks like. We'll call that pixel font. We're setting our font to pixel font. And then we're gonna go ahead and render it. Ooh, it looks so tiny. Does it look better at 8? Okay, yeah, it does. So maybe let's see if 10. You know, you gotta have like that multiple of whatever for it to be smooth, I guess. So maybe 14. Does 12 look like crap? No. Maybe 16. Yeah, 16 looks fine. So 16 or 8 looks fine. So we just need to rise it up just a bit, and we'll put it, that is in our play state, and we'll go maybe minus 16. Okay. Nice. Oh, it is so laggy. I'm gonna have to kill. I think I'm gonna have to kill the Matrix. As cool as it is. It's just not serving us right now. And you know what? It's still laggy, so maybe that's not the problem here. I don't, it all of a sudden got laggy, so I don't know why. Anyways, I think that's a good stopping point for today. Let's get it a little bit, move it down like a pixel. So instead of -16, let's do -15, and then that looks good. Just for now, just to have something. And we'll call that a day. We'll look at all we've done to kind of show you guys. It's not too much. It was a decent amount of boilerplate to kind of get started, but it really wasn't a lot. We take a look at our main. We're requiring push for the resizing, class for object-orientedness. We're requiring our state machine dependency. We're doing a title screen and a play state, and then a player class that we made, a constants file. We set a couple settings. We set a font. We set some sounds, which we aren't using yet. We set our virtual resolution. We set our state machine. We change our state machine to play state. We do the actual resize using push. We have a couple of functions to handle our love keyboard tables to populate our love.keys pressed, so that we know if a key was pressed. And then, yeah, we're updating our state machine, we're flushing our key presses, we're rendering our state machine, and we've got a display FPS function that we're not using. Most of the code was here in our Kavoth class, and we're just doing this, which gives us the little character. So we have a start. We have a start to the game. This is not very impressive by any means, but for one day amount of work and for it to look like Link's Awakening, that's not bad. I want to figure out why it started lagging all of a sudden. And see if I can fix that, because that's pretty laggy on stream, huh? So hopefully we can do that. I think it might be A-Sprite eating up a lot of it. So if we save this, if we quit A-Sprite here, does it run faster? No, not really. So I'm not exactly sure why it started getting slow. I feel like it started getting slow as soon as we did our player class, but I don't really imagine that would slow it down that much. Anyways, we've got a decent start. You know, if we take a look at our get diff, we'll see, and actually we haven't. This is our first commit, so we can't do a get diff because there was no files in there. So what we're going to do is add everything to the staging area with a commit message saying initial commit, have working screen and basic character control. Git push it. So now we have our commit there. Cool. Let's make a notes file for us. So right here, we're going to do a %notes here. And this is where we're going to be doing our little updates to our game. So it's like today, we've got added Game Boy resolution screen, which we did. We can do add both sprite, moving both with input, what's it called? Not snapping, clamping movement, for both, and we'll say, so like this is all stuff we've done to give us a little note file, and then we also added the HUD stand-in, so we could say add HUD stand-in, which we did. And then next episode, what do we want to do? Do we want to put in all of our camera constants? We can do, not our camera constants, our color palette constants. And I like to do like a to-do and then a next episode and kind of plan it out like that. So to-do, we can say add all colors to color constants palette. And then we don't want to do the sprite variations just yet for the Kvoth. Like, we don't want to get that far into it. We want to do more beneficial stuff before that. It might be nice to add like a ground tile. Maybe we'll do that tomorrow. We could do a repeating ground tile. And then maybe we'll flesh out, I would love to be able to figure out how to have a whole atlas of images and to say, to have a code. So it's like 1 is all our dirt patches, 2 is all our grass patches, so that we can build out a map. Because every time on this screen, every time you reach like a side, the screen kind of scrolls and you're on a new screen. So I'd like it to be that you can set up the whole map for whatever quadrant we're in. Just by like a number codes, like set up one table with all the number codes for all of the palettes so that we can draw each quadrant of our game. That's going to be a big one. And then scrolling the screen and figuring out how the love.graphics.translate or whatever works. That's a big one to add. And if I can figure out, like I feel like the sooner I figure out the screen looping, the better off we're going to be in terms of just how much we can get done. So ultimately, if we get the, if we can do the draw a whole screen using tile key codes, that's a big one. And then the other big one is translating all images off screen when Kvoth walks off screen. Those two are big ones. Like the second we've got those two things, then we're in business. Because then we can worry about level design or art design, sprite design, and then it'll look like we've got a game, and then we just build different squares. So like you walk into the Waystone Inn, and we can build out the art for that, having some programmers stand-in art for a bit while we work on figuring out all the nitty-gritty. Because I feel like drawing the screen using the tile key codes and translating all the images off when we walk, once we get those two things figured out, we're in business. So I don't think that's going to be next episode, but what I'll be doing, since I'm planning on streaming this as many days as I can in a row, you know, try to do it every day. What I'm trying to do is I'll study how to do these things kind of one episode ahead of time. And then, so like tomorrow's episode's going to be making the ground tile and doing the colors to the constants, the color constants. So like tomorrow's going to be that. And what I'm saying is tomorrow, before I do the episode, and tonight and tomorrow morning or whatever, I look up techniques for how to try to tackle this stuff, so that I'm not going in totally blind for the episode, for the stream. Because that would be nice if I can kind of not have to guess from scratch, but to be like, okay, I think I know how to do it, and I'm gonna walk you guys through it, see if we can pull it off. And then keep going. Like, we'll have to figure out, like, I know I want him to play the lute at some point, so we might add some music making to the stream. I'll probably do new Sonic Pi code at some point. More Name of the Wind inspired. And then, yeah, I'm gonna do another commit here with this new file, and I'm just gonna say that we're adding a notes file. And then I'm curious if our game is still laggy. Yeah, it is still laggy. I would like to get this fixed, but I feel like it's because I'm streaming and recording in OBS, so we'll see. But anyway, thanks for watching the stream, and I'll catch you guys tomorrow.